Okay, so a very good morning to all of you, and wish all of you a very happy Chhat Puja. So, am I audible?
Yes, sir.
Yes, sir. Good morning, sir.
Yes, sir. Same to you, sir.
Am I audible to all of you? Okay,
Yes, sir. Yes, sir.
okay. So, firstly, today we'll be discussing about the instruction set of another part. I have broken those total instructions into several parts. Okay, so our third day of instruction set. So, just I am going to this one. You can just remember that till today, till the earlier class, uh, we have discussed about the move data instructions. Okay, so and obviously this exchange data instruction. Okay, here the bit level data move instructions are there. So what are the bit level data movements? You know, there are some amount of space that is available in the internal RAM area that is known as the bit addressable area. Okay, so this bit addressable area can be accessed by this particular bit level data move instructions. Apart from this, you can just remember the flag registers that some bits are bit addressable, and there are some portion in the internal RAM area that includes the special function registers. Some of the special function registers are also bit addressable. Okay, so this bit addressable area that simply means that you can access the particular bit by using the instruction. So coming to the first instruction, that is move c comma a c comma b, that means copy the address bit, copy the particular address bit to the carry flag. And for example, move c is the carry flag. So here in the example it is written move c comma 7fh. That means if in the 7f memory location particular internal RAM location, it can store 1 bit data. Okay, particular single bit. So bit means either 0 or 1. Okay, so suppose 1 is there. Okay, in the 7fh memory location. Okay, so after the instruction, the carry flag in the PSW register, that will be whatever the value was in the carry flag, that will be replaced by 1. Clear? And similarly, the reverse case, the copy the carry flag content, copy the carry flag content, that is suppose the carry flag content is 1, then the particular content will be moved to the content of the carry flag, that will be moved to the 7fh memory location. Is it clear, or I should repeat?
Clear, sir.
Okay, so this is the simplest instruction that involves the bit level data movement in operation. So there are some I'll give some assignments later on. We'll come back to this. Now here comes the logical operations. So here some specific logical operations are operated in the 8051 microcontroller instruction set. So there are some what are the logical operations can be done? That is AND operation, OR operation, XOR operation, complement and clear. These 5 operations can be done. So complement and clear, there is the simplest one, and OR and XOR, these 3 instructions are will be discussing. So first we'll discuss about the AND operation. Okay, so first mnemonics you can see in the table, ANL A comma hash n. Hash n means 8-bit data. Okay, and hash means this is the immediate data. So ANL A comma hash 60H, that means what? That means whatever the data is present in the accumulator or A register, that will be bitwise AND with this 60H. For example, 60H means just I'm writing 0 0 0 0 0 1 1 0. So this is the 60H a binary conversion. Okay, suppose ANLA, that means in the A register, suppose what 0F data is there. So 0F means 0 0 0 1 1 1 1. Okay, so this is the content of A register. Clear? And this is the content, and this is the conversion of 60H. Clear? So after the execution of this ANL A comma hash n, that will be bitwise AND. That means the result will be 0 1 and 0 and 1. That means 0. This is also 0. This is 0. This is 0. 0 0 0 0. Okay, so after the instruction the result will be 00H, and that will be stored into the accumulator or A register. Clear or not? This is clear or not?
Clear, sir.
Okay, any question you can ask. Okay, so coming to the next instruction, that is ANL A comma address. Just you can see that AND each bit of A with the same bit of direct RAM address and put the result in A register. Clear? And ANL A comma RR, that also means, okay, let us discuss the second instruction, that is ANL A comma 80H. That means whatever the content that is stored into the 80H memory location, that will be bitwise AND with the A register, and the result will be stored into the A register. Okay, and in the third instruction, that is same as move one, data move instructions, that is and each bit of A register with the content of this particular R register. That means RR means R0 to R7, any register in the register bank, and the result will be stored into the A register. The fourth one, that is at the rate RP. So can you tell that what is the operation going on here? ANL A comma at the rate RP.
So the content at the address of RP will be AND with A register, and it will be stored in A register. The result will
Very
be
good.
stored in A register.
Very good. Very good. And what is the fourth one?
So, the content of accumulator will be bitwise added with the ad address, and it will be stored in the address.
Yes, but that is not the address, the content of the address. Okay.
So the content of the address.
Yes, very good. And the last one is the immediate, again immediate data, the content of the address and the immediate data, that will be bitwise and the result will be stored into the address, particular address. So whatever in the ANL operation, whatever the instruction is, just see this after the mnemonics, whatever the register or address is, the result will be stored into this particular location. Okay, now for the first four instruction, the result will be stored into the A register, and rest of the two instructions, the result will be stored into the particular address. Okay, Now the logical OR operation, the same operation is going on. Okay, that is OR with the immediate data, and the result will be stored into the A register. Again, this is the bitwise OR. Okay, now whatever the data is, in case of this particular example, sorry, in case of this particular example, this 60 will be converted into its equivalent binary form, and the content of the A register, that will also be converted into its equivalent binary form, and they will be bitwise OR, and the result will be stored into the A register. Clear or not? Okay,
Yeah.
and the rest of the things are same as the AND operation. Same operation. Whatever you are doing with AND operation, you can do this with this OR operation also. Okay, now XRL is again same. You know that XOR, do you know what is XOR? Can you tell me that what will be the content of the accumulator or A register after the execution of this particular instruction, if the content of A is, sorry, content of A is suppose 76H. Can you tell me? So simply this 0 1 1 1 6 means 0 1 1 0. Okay, and 60 is 0 1 1 0 0 0 0 0. Okay, so these two will be XORed. Okay, and the result will be stored into the A register. Clear? Now you can clearly find out the value, I mean the result with XORing this. Okay, and similarly the rest of the things are same as the and OR. Okay, so is there any questions on this logical XOR operation, and operation and the OR operation? You can ask if you are having any questions. Okay, I think there are no questions, so I'm resuming it. Now complement operation and clear operation. Okay, only one single operation is there. We can clear or we can complement the content of A register only. Okay, in this particular particular instruction, that CLR A, that is whatever the content of the A after the execution of this particular instruction, the content of A register will be reset to 0. Okay, every bits of A register, 8-bit register, this is I mean the A register is the 8-bit register. This 8-bit register content will be 0. Okay, and CPLA, whatever the content of this A register, that will be complemented by, okay, and the result will be obviously the result will be stored into the A register. Okay, and as there are no 8-bit data or 8-bit address is there, so these instructions are single byte instruction. Okay, now there is an important note, that is no flags are affected by the byte level logical operations unless the direct RAM address is the PSW. Okay, the direct RAM address, if the PSW is the internal RAM address, then no flags will be, okay, then the flags will be affected. Okay, So this is the whatever we have seen, that is in this case you can see this ANL, all the operations, these all the operations are doing by 8 bits. Here also the odd operations are going on by operating 8 bits of the particular register or any 8-bit data. Okay, but here bit level logical operations are going on. Now bit level logical operations can only be done with the carry flag. Okay, now you can see this ANL C comma B, that means the content of the carry flag and particular bit is ended and the result will be stored into the C register or the carry flag. Okay, similarly that hash means sorry, not hash, there is the backslash, that and ANL C comma backslash B, that is and the content of the carry flag and the complement of the particular bit and put the result into the carry flag. Clear? Any questions you can ask if you are having any confusions regarding this bit level logical operation.
Sir, please give some example.
Okay, so suppose this just a minute, yeah, so this 7070H memory location is a bit this particular memory location is located in the internal RAM area, internal RAM bit addressable area. So this particular address can store single bit of data, either 0 or 1. Now suppose the content of carry flag, that is CY, okay, that is 0. Okay, and the 70H memory location, that is 1. Okay, now after the instruction, after the execution of the instruction, this 0 and this 1, that will be ended. That means the result will be 0, and this 0, that will be stored into the carry flag. Okay, clear or not? Now you may think that if the content of this particular carry flag is 0, then always after the execution of this particular instruction, the carry flag content will be 0 only. Obviously a single bit 0, that means AND is 0. And in this case, in this second case, simply this 70 here 80H is there, so 80H memory location is having the having a value of 0 or 1, whatever the value is, that will be first complemented, and that complemented value will be ended with the content of carry flag. Clear? Now is it clear?
Yes, sir.
Okay, so similar case is going on with this OR operation, and CPL C, CPL B, that is the complement operation, whatever we have seen in the earlier case, CPL A. But as this is the bit level logical operation, so they are considering only the carry flag, only a particular bit in the internal RAM area, like this. Okay, similarly clear and set bit. So set bit is the thing, set bit and CLR, just let me mark over it. This CPL, these are complementary operations. The CLR and SETB, these two, their operation are just complementary. You can see that CLRC, that means clear the carry flag to 0, and CLRB, that means clear the particular address bit that is located in the internal RAM area, that is set to 0. But in case of SETB C and SETB B, that is set the carry flag to 1, that is SETB C, and set B B, that means set the address, particular address bit in the internal RAM area, that is set to 1. Clear or not?
Clear.
Okay. So just a minute.
Sir,
Yes, tell me.
sir, in this operation, the address bit always 0 or 1.
Yes, obviously, because it can store only 8 bit of data. Sorry, a single bit of data. Okay, because this is the bit addressable area. So particular address can store only a bit. So how many bits are there? Bits are nothing but binary digits. That is 0 or 1. तो 0 और 1 ही होगा. इसके अलावा तो और कुछ नहीं होगा इंस्ट्रक्शन में.
Okay, sir.
Okay, so just record your attendance now. Once done, you can leave your classroom. Okay. After the attendance, you can leave the class.
Okay, sir.
Okay. Thank you so much, everyone.
Thank you, sir.